Hi everyone, my name's Junkie, and today we're back on the AI series, or the Intelligent AI series. Now today we're going to be starting to code the draw event and the second or run first population step in this stage. But to start off with, there was just one little thing I forgot in the initial population, and this is to set the time. So we did actually make the max time variable, but we never set our alarm to be that. So all we're going to do, alarm 0 equals max time, and then we're going to increment the mini step. So what this means is we reset, or we set the initial AI directions up, then we set our alarm equal to the right amount of time we want to spend on it, and then we increment the mini step, meaning we move on to this. So for this run first population kind of thing, all we're going to do is set a variable we haven't made yet, so we do need to add that in. So that's not how we spell weather. How do you spell weather? Not like that either. We'll just go with that. Whether or not to draw. Cannot type today. So we're going to call this draw step. Initially this is going to be equal to false, and this is effectively just going to enable a draw event, because otherwise it would do it all the time. So as soon as we go into stage 2 or case 1, sorry, we're going to set this equal to true. So we're going to leave the calculate the fittest for the moment, because we can't calculate it until it's obviously moved. And we're going to go into the draw event. Now the draw event is a little bit tricky, so we are going to code side by side like this. We're in fact going to full screen this, and we're going to go over to here. I'm going to full screen this as well. So this does look quite complicated to start off with, but we're going to talk you through it. I have wrote a little note here as well. Should be kept to a minimum. This is important because draw events use up a lot of RAM and GPU. So if you have a big draw event, it's going to cause a lot of lag. So you want to keep all the big calculations and stuff into the step event, and this is why we use draw step here, instead of just putting all the code from case 1 into the draw event. So first of all, if draw step, pretty simple. Again, I've already taught you through why we're doing this. And now we've got a few things, so we're using this loop again. This loop, as I say, will come up a lot. I do actually, I do have to say as well, whilst I'm coding this, that GameMaker 2 is growing on me because of the things like you can autocorrect like that. If you just press enter, it loads. It's quite nice. Quite a nice feature to see. So yeah, we're going to start off simple. We're not going to use all this. We are just going to have this bit of code here. I should have typed that out. Why did I not type that out? But what this does is it draws a circle. This is a first circle in white, and we're going to draw a black outline of that circle. But you'll see here there's a few unknown variables going on here. So there's two arrays, AIX and AIY. I'm actually going to code these now. We don't need to be a double array, so we're just going to make the same for loop there, the second one, the I, and we're just going to say AIX I equals -1, AIY I equals -1. In fact, we're going to change that in a minute, but for the moment we can just leave this as is. What this is the specific unit, so the circle, its x coordinate and its y coordinate. This is holding an array because obviously we have lots of these circles, so it just makes it much easier to do it like this. Okay, so what this does is it just draws it at its x coordinate and at its y coordinate. It's pretty simple. There's not much going on there. Again, there is more to do here, but this is later, after we've got past that first initial step. That's always the first aim, is to get the first step to work. Anyway, we'll go back to the create event for now, because as you can see, these are -1 and -1. Now, if we ran this now, what would happen is that the coordinates for every single population would only be -1, and obviously that isn't on screen, so the first position it would be at is off screen, which that wouldn't make any sense whatsoever. So we're going to have some starting variables. So we'll call it x start equals rebirth div2, and the y start equals room height div2, and we're just going to set these equal to here. This means that all the population will start within the center of the room. So if we were to run this now, we should see like a big blob in the center. Oh yeah, I'll just full screen this for the moment. We need to also go into the object main and do not object main, but the room. We need to work on the room a little bit. So first of all, we're going to rename it because I don't like the layout of that. Going to call it room main for consistency. We're going to change the color a little bit. So I think a grey worked best when I did it. And we're going to add the object in. Save, close this down, give it a run. Now we should see, you see that? There, that's our whole 200 population. Obviously they're all drawn in one place. There's no movement at the moment, which isn't amazing. So we're going to add a little bit of movement in now. So where we're going to do this, we're going to need a lot more variables going on here. So we're going to set these up now. We can use this same for loop because it's a universal for loop. We're going to use it a lot. You know, we can just keep this as is. We're going to go with the most simple one to start with, AI moving. So simply, is the AI moving? I mean, we're going to start with true because they all start moving. Now that's pretty simple. Honestly, there's not much to that one. Next, current step equals 0. We have lots of steps going on here, so it can get confusing. So steps is the generations. This is the stage within the generation. This is the stage within the movement. So you kind of got to think of it as levels. So this is the biggest level. This is like the medium level. This is the smallest level. So this is each individual step in the game. So the dog again. Where are we in that step? So out of 50, where are we? This means each step we're changing the direction, so we're moving somewhere else, and it adds the random step to it, but it also means that we can count how many steps it's taken, so we can show that it's progressed and that each time we've got less time. So that's important to have, and it's quite useful. Final steps. Again, this isn't that hard. Like, you just kind of got to think about this. So final steps is literally current step, but it gets set to the current step when it stops. So when it stops moving, when it's reached the destination, this holds how many steps it's taken to get to that destination, whereas this just keeps incrementing until we reset the generation. So that's all them kind of variables set up. I don't think there's anything else that we need. It's all kind of simple. We'll just code a little bit of this and then we'll have to call it a day. But for the moment we've set up our drawing. Let's do this. If current step I, so the current step for the one we're on, is greater or equal to minimum steps. Do we not have minimum steps? no, not yet what I'm on about. We don't need this at all for the moment. We can get rid of that. Let's do the if AI moving thing, because that's probably the most fun. So if we are moving, we want to make this thing actually go in some sort of direction. AI x I plus equals, and this is where the maths kind of stuff comes into it. So cosine AI directions I current step I. Yeah, we need to close that as well. And then here I've just put times 10. This doesn't really matter as long as they're both equal. We don't actually need a bracket there either. So let me talk you through what's going on here. Because we did radians, what we can do to convert radians into a vector is by using cosine on the x and sin or sine on the y. So it's the same thing for this, it's just sine AI directions I, and then the current step, again this just says what step we are on within the movement, and then times 10 is just to make it move a little bit faster. Then what we're doing, we're setting the next direction, so where we're going next is going to be just random. So I current step, I'm going to just add 1 to that, plus 1 equals, and then we're just going to use the same stuff that we used earlier, the random degree to radians thing, random range, like that. So I mean, potentially we could have done this AI directions in the create the initial population, but just by doing this I feel it just works a little bit better. It's obviously less efficient, so we could possibly go back and change this a little bit. For the moment we'll keep this as is. Current step, we're just going to increment that, and along with final step as well. Final steps we're going to increment as well, just so we keep track of where we are. Right, I think that's our movement done. Yeah, you can see that. We have our first population. Hooray, we've officially made our little friends. So you can see they're all moving randomly. They all scatter as well, so they all do move in a general direction outwards. And then what we're going to do is place like a finish point like here, and then when they collide with it, we'll work from there. So we've done this first population. We do need to put a little bit of code here to check whether they've reached the destination. We need to calculate the fittest, then we need to do all this for the second population, and then we will have to go back and make some changes to this to make it work with that. But for the moment, guys, I think we've made some good progress. We've got something working on the second episode. This is definitely better than I normally do. But anyway, if you like this video, remember to like, subscribe, what do you guys want to do, and I will talk to you in the next one.